Thank you very much. I am Yazane from NTT Data, QCI and Tenasis members. Thank you very much for giving us this invitation to this wonderful session. And this session is government and analyst, and there are a lot of presentations and wonderful analysis. But I'd like to show you the overview of NTT Data at the outset, but I'd like to focus on the engineering because our company is more focused on the engineering. So rather than talking about the analysis of the marketing, how we are looking at the overview from engineering perspective is what I would like to focus on. But we're not specifically specialized in any particular hardware, so we like to give you just overview from engineering perspective. And I would like to talk about strategies from short, mid, and long-term perspectives because we have to distinguish between these periods. That's the sense that we have from the field. Then the companies that would like to use quantum computing, how they can distinguish the usage and what sort of time frame they have to look at. That is what I would like to focus on when I share our view with you. Now, at the outset, as I said, I just would like to clarify our positioning. Within NTT Group, there's NTT Data, and well, that's where we're from. And if you are Japanese people, you're familiar with NTT, but NTT is specialized in telecommunications, and mobile communication is taken up by NTT Docomo, NTT East, and NTT West for fixed line. And as for IT solution and system integration, we have NTT Data as one of the sections for NTT Group. As for quantum research, technology research, there is a section in NTT per se, and there is some development being done, but NTT Data is taking its path, and sometimes the hardware is used by the NTT Data to provide the best solution to the customers. And there are two distinctive features, at least here in Japan, the finance or government agencies. It's not just limited to the services in these industries, but we're covering general areas, and we're not specialized in any type of hardware. So we like to combine the best hardware and solutions, and that's we believe is our mission as we engage in our day-to-day activities. And there's the Innovation Center in NTT Data, and that's where we're from. And there are three specific features that characterize our center, and it was launched last year. And as a global organization, for NTT Group, it seems to you that NTT is focused on Japan, but NTT Data per se has more than half that are originated from overseas. So, and also it's not just the quantum technologies, but for new technology use cases. In various countries, there are new trials ongoing. So the results of those new pilot system is captured as soon as possible, and then look at other applications in other countries. And we have to be agile enough. And in order to do that, we have launched this Innovation Center as a global organization. And I'll be talking about the Japanese activities, but I have a member from Germany talking about overseas examples toward the second half. Now, the second feature of Innovation Center is that how technologies can be used to be materialized gradually, but we are at the early stage. And quantum, since in quantum technology as a whole is taken up by Innovation Center at the early stage. And then there are several different phases following that. But when the bud is still emerging, we believe that quantum technology is still nascent technologies. So how technologies are used and how to monetize them is something that we are just about to start to look at. And so quantum inspired and others are also the signs that we're looking at. So which phases that we have to look at in the quantum technologies? We are also having that perspective. So this particular technology should be used in this particular span or time frame. That is what we are proposing to customers. And I'm talking about innovation center too long, but on a needs basis, we are capturing the use cases. That's what we're doing. So research itself is done by NTT Research Institute on the full scale, but what should be used for meeting the specific customer needs is something that we're looking at. So rather than looking at the technologies and their applications, but we just consult with the customers, and as a result, in order to realize the needs that customers want to realize, if there are technologies available from NTT, then we will proposing them, or we're working together with the customer to specify those technologies. That's the positioning that we have. So quantum technologies as a whole and where it should be used or use cases is something that we can have a bird's eye view of. That's probably why we have been invited to this session. So I'd like to talk more about that. So I've been talking about this from NTT specific perspective too long, but let's look at the whole picture again. As was said in the previous sessions, the market is steadily increasing and expanding. And as for software, the number of startups and investments are also increasing, and how to make it easier to use. The SaaS services are increasing, and so that user can use it more quickly, or trials and errors can be made more easier. So I think the fundamentals are now becoming ready, as you may see. And what we also feel is that quantum talent, how you can utilize the quantum talent. The talent is still in shortage, and we also have a team to capture and hire those talent. And there is intense competition for good talent in this field. That is exactly why we're looking at this theme. In what time frame we have to achieve the usage of the technologies, and then what sort of talent and personnel should be assigned. So we have to have more granularity to have the appropriate organization and personnel to meet the needs. And also, the technological advance is steadily being seen. All the way to the left is the Cabinet Office report, the number of qubits and the number of years. And this is the IBM statistics, but actually the qubits have been realized on a more quick basis. That is quite important. So we're discussing with customers how to look at quantum technologies, but there's polarization. There's a lot of expectation, and some people say that everything can be done by quantum computing. So there is high expectation in one camp, but then the other camp is saying that there was a too high expectation originally. So actually, it turns out that it's not meeting that high expectation. So we have to provide the right information. So hardware is growing quite rapidly, but to users, what is happening with this advance of hardware? That is something that we have to capture. At what time frame, what can be done is something that we need to capture and understand. Now, this is what we believe is going to happen. And this is what is going to happen in what time frame. There are a lot of different quantum technologies available, but in ultimate basis, fault-tolerant quantum computing can be used in unlimited number of quantum qubits in a free manner. Maybe that is the way down the road, but if that is the ultimate goal, then before 2020, maybe this is the area that was focused on. But of course, that is going to be the long-term goal. and that should be the long-term goal. But before all that, what sort of business applications are made? It will be made available. That should be looked at in a different perspective. In other words, in midterm perspective, you have to look at NISC and quantum annealing, because technologies are developing steadily in this area. So there are use cases that can use those technologies. And also, the real impact from quantum computing is the quantum supremacy or quantum advantage. Where would that lie? I think there are a lot of different views from different entities, and you have to discern what is right and how and when it can be used. You have to look at that and capture that in a middle term basis. If that is what you want to do, then you have to take this midterm strategy. But if you want to have more quick win and realize advantage, so there are classical, broad classical methodologies that you have to compare to. And what you have to focus more on what you would like to achieve, and requirements have to be made clear, and then you can look at what would make it possible to achieve them. And from that perspective, you have to look at that in a short-term basis. So in your time axis, what is the focus that you are looking at? That is something that you need to see. And also, which use cases are available at what time frame. There are several that are already being talked about. So what sort of problems you would like to address? And short, mid, long term, what sort of approaches will be taken? For example, one example that I can show you is the portfolio optimization in financial industry. What is often done a lot in this industry is that be it classical method or quantum-inspired method, there are a lot of different methods that are available. So how effective they are. There are a lot of papers that are describing them. So whether this would fit your company's strategy, if that is the short-term strategy, then in the mid-term strategy, quantum annealing optimization or QA methodologies, this is how effective it is right now, but in 5 or 10 years' time, how much progress can you see, or are they going to be the feasibility? So that's what you have to look at. And also, if in the world where there is a complete error correction, what can be done might be the ultimate goal. So where you would like to have verification, you have to focus on that when you consider quantum computing. And then as you look at this, so what the customers want to do is something that needs to be clarified. But if I can just give you the overview, what is the business impact that you would like to achieve? That should be clarified. And for example, in the midterm, NISC, if NISC methodology is used, you can estimate to what extent you can go, what would be the potential. You have to discern it. And then integration is very important. From the current method, how smoothly you can find a good use cases and shift to quantum computing is something that you need to look at. For example, if you're solving optimization problem, then quantum-inspired could make it possible to do implementation, and then but shifting that to gating is a totally different matter. So in the time frame, what sort of time frame you have to look at is something that you need to consider. And also this can be used in other workflows. So by having that whole analysis, then you can set your goal at appropriate area and timing. I'm sorry, I was just looking at desktop analysis, but the NTT Data is an engineering company. That's what I said. So what are we doing? And more specifically, I'd like to just give you the examples, short, mid, and long-term strategies. As for short-term strategy, what they want to do, regardless of the methodologies, what is the value that you can achieve right now is something that you have to focus on, as I said. So one of the examples that we have done is the flavor optimization. synthesis of information. Komi Happo is a startup that is originated from Osaka University, and we worked with them. And with the nose, you can sense the smell, and that is being digitized. That is the technology that they have. So smell, odor data is very complex, and sometimes there is a chronological changes, like you feel the sweetness immediately or later. And there are a lot of optimization problems in order to have target new. So what sort of blending should be done to reach the optimum smell or odor? And they were struggling, and they thought that the quantum annealing could be used in a long-term basis, and they were taking on this challenge, but they want to commercialize this in this year or next year. So as we consulted with them, that has been made clear. And for example, this the number of fragrances should be increased, or the diffuser to blend the flavors would be presented in front of the customers to produce various odors. But the set of the flavors that can be used in front of the customers is very limited. So how you can achieve a wide range of fragrances with a limited number of flavors. So there you were able to use the quantum technology. So what was what is it that they wanted to achieve was quite clear, and in order to achieve that, what sort of technologies are used is something that we were able to identify. But from the midterm strategies, where you can have the methodology advantage, that is something that you have to focus on, and there are two different cases. In the last fiscal year, I shared this with you, so I'll be very brief on this matter. For example, the D-wave, which is doing the quantum annealing, compared to the existing methodologies, where you can see the advantage has been analyzed quite in detail. The sport scheduling is the application. Home or away game or match scheduling. And of course, if you take enough time, then you can solve this, and there is no law that should be applied. But if you're talking about this type of problem, then if you compare the annealing and the current method, then compared to grubbing, there's no constraint that is, or there's no speed that is lost in the quantum annealing. So home and away method, maybe you don't have to be so quick in solving this problem, but you can achieve advantage in other areas if you use this method. That's why we use this. And there are other examples, so I'd like to ask Kristen to explain about.
The example that I actually want to show for the midterm quantum cases, use cases here, is in the field of reinforcement learning. So reinforcement learning has gained a lot of attention over the last years, specifically because of the huge breakthrough, for example, from AlphaGo. But these models are notoriously hard to train, right? There's a lot of challenges involved, so we had a look at that, and what makes them very interesting for midterm use cases is pretty much that they're driven by an interplay between an actor and a critic, which are small neural networks. So the size of these systems is very, very good for the NISQ era, and so we tried out to replace these models with quantum devices and found a clear advantage in the number of trainable parameters that could be used in the midterm, so to say, and to build up on this improvement. But what is about the long-term strategy? And in the long-term strategy, we've seen it still makes sense to have a look at the fault-tolerant quantum computing application, even if they're a little bit farther away, and even if we can do that right now just on paper. Because from knowing and understanding what the implications of these of this technology is on your use case and estimate the timelines, you can really build up a solid solution strategy. And an example here is, for example, the use case that we did in this case with BMW, where we really had a look into the full quantum fault-tolerant quantum long-term vision, so to say. On paper, we were really studying what is the long-term advantage in a optimization case here. In this sense, it was optimizing the number of pre-production vehicles that are used for testing. So we studied this to find the long-term goal and the long-term benefits and also estimate timeline. But on the same time, we also looked into what is actually the best result that we can achieve today. And from these both extremes, we could derive a strategy to develop a solution that we're actually doing right now that is able to use, solve the problem right now on the classical, to switch to NISQ-era devices to exchange the solver, so to say, and then basically exchange it in a later stage when we see fully quantum tolerant computers. And so we build a solution now that is future-proof. Thank you.
Thank you very much. This is our last slide. I'll be very brief to summarize. So what I wanted to have you as a takeaway is that you identify the appropriate use case. That would be the ultimate path to find the killer use case for quantum computing. So, and we'd like to work together to identify that. Thank you very much for your attention today.